Hello friends, welcome back to our channel. In today's video, we are going to learn about vectors, which is an important topic in physics. We are learning vectors from physics point of view and not from mathematics point of view. The topic vectors is especially important in learning the problems in physics of class 11th and 12th. So let's start with the topic vectors. Now, a vector is any physical quantity which has both magnitude as well as direction and which obeys the parallelogram law of addition or the triangle law of addition. So let's write any physical quantity which has both magnitude as well as direction and which obeys the parallelogram law of addition. This represents parallelogram law of addition. We are going to understand the parallelogram law of addition or the triangle law of addition later on. Now, we are going to learn about the representation of a vector. How can we represent vectors? Representation of a vector. Let us consider this directed line segment. Therefore, we can represent a vector by a directed line segment. Now, let this be A and B. The point A is known as the initial point or tail, and the point B is known as the head or the terminal point. Now we know that a vector has its own direction. So the arrow represents the direction of the vector. That means the arrow of this directed line segment represents the direction of this vector quantity, and the length of this directed line segment represents the magnitude of this vector quantity. Now in practice, we usually ignore this concept. This length usually denotes the magnitude of the vector quantity. Therefore, the magnitude of a vector can never be negative because length cannot be negative. So we can rub the board. And we can write the length of the vector represents its magnitude. Therefore, the magnitude of a vector quantity can never be negative. It can be either 0 or having some positive magnitude. It can never be negative. Now we are going to study how to represent magnitude of a vector. Suppose we take an example of this vector, PQ vector. It can be represented as PQ with a directed line segment over it. This can be represented as PQ vector. Now its magnitude can be written as mod of PQ vector or simply PQ. You can pause the video and note down the things which I am writing. Now, types of vectors. Basically, you can divide vectors into two types. The first one is free vectors. And the second category is fixed vectors. Or localized vectors. According to its definition, we can move the vectors parallel to themselves. These can be moved parallel to themselves. For example, we have the velocity vector, the acceleration vector, velocity vector, then we have acceleration vector, etc. And fixed vectors or localized vectors are those vectors which are fixed, which cannot be moved from their position. For example, the position vector or force vector. These vectors cannot be moved from their original positions, otherwise their effects will be different. So these cannot be moved. From their original position. Please note down. Next, we are going to learn about collinear vectors. Collinear vectors. Two or more than two vectors are said to be collinear if they point in same direction or in opposite direction. That means we can write two or more than two vectors are said to be collinear if they point in same direction or in opposite direction. For example, let us take this vector PQ vector, and let us take another example, this AB vector. These two vectors are parallel to each other and pointing towards the same direction. So these PQ vector and AB vectors can be termed as collinear vectors. If PQ P dash Q dash vector is represented by this arrow and A dash B vector, A dash B dash vector is represented by this arrow, then these two are non-collinear vectors. It is not necessary that the magnitude must be same. Actually, what matters is its direction, whether it is pointing, whether both of them are pointing in the same direction or in opposite direction. Now we are going to do a simple exercise. Suppose it's in this reference frame xy coordinate system, this is O, we are given a set of points. This is A1, this is A2, this is A3, and this is A4. In this question, we are required to draw the vectors A1, A2 vector, A2, A3 vector, A4, A1 vector, and A3, A4 vector. Remember, when it is written in this way, A1, A2, A2, A3, then this point represents the tail, and this point represents the head of that vector. So now we can draw. This is A1, A2 vector. It should be straight. Next one is this is A1, A2 vector. Next one is A2, A3 vector. It means this. Next one is A4, A1 vector. Then the fourth one is A3, A4 vector. These are the four vectors we are required to draw. Thank you. Next, we are going to learn some algebraic operations of vectors. Algebraic operation. The first one is scalar versus vector. Suppose we add or subtract a scalar quantity from a vector quantity. Scalar plus minus, this any scalar quantity, this is plus minus any vector quantity, then this statement is meaningless. It has no sense. Suppose, next one, for example, we can take 5 Newton force acting in this direction plus 5 Newton with no direction, then this is meaningless because this is a vector quantity and this is a scalar quantity. That means when we add or subtract a scalar from a vector, then it is meaningless. Next, we are going to see multiplication of a scalar with a vector. Scalar multiplied with a vector quantity. This statement is meaningful. For example, let us suppose we have a vector A vector and we are multiplying this with any scalar 5. This can be written as 5A vector. It is meaningful. The meaning of this statement is the magnitude of the vector A will be increased 5 times the initial one, and the direction will be same as this is a positive number. If we had multiply this A vector with negative number, for example minus 5 multiplied with A vector, we will get minus 5A vector. Then in this multiplication, the direction of the vector A got changed and the magnitude of this vector has increased from 1 to 5 times. For example, suppose this is A vector and we are to draw 2A vector, then the length will be double this length. It means it will be like this much, and it is 2A vector. If we are going to multiply it with minus 2, then we are going to get this vector 2 minus 2a vector, and this is the meaning of multiplying scalar with a vector quantity. Now when we are going to multiply a scalar with a vector, then we do not require to put a cross sign or dot sign in between them. For example, 5 cross a vector or 5 dot a vector, both these quantities are meaningless. Please note down. Let's write the meaning of multiplying a scalar with a vector quantity. If we multiply a vector, this is the vector quantity, with any scalar k, then the resultant vector will be Ka vector. This will be the resultant vector, and its magnitude will be mod k times its initial magnitude. And the direction of Ka vector will be either in direction of a vector if k is greater than 0 and or in direction of minus a vector if k is less than 0. This is the meaning of multiplying a scalar quantity with a vector quantity. We can also represent it as k a vector. Now, if we are to find the magnitude of this vector, then we can write it as this magnitude of k a vector. We can write it as magnitude of k multiplied with magnitude of a vector, and it can be further written as k times a vector, k times magnitude of a vector if k is greater than 0, or minus k times mod of a vector if k is less than 0. I hope you all have remembered the formula. Mod x is equal to x if x greater than equal to 0, and minus x if x is less than 0. Now another point is, when we divide a vector quantity by a scalar quantity, any vector quantity divided by a scalar quantity, then its meaning is 1 by scalar times the vector quantity. One by scalar is another scalar, so this is a scalar quantity and this is a vector quantity. So that means when we are dividing a vector by a scalar, we are multiplying a scalar, another scalar quantity with a vector quantity. So it is also meaningful, it represents the same thing.